All right, welcome to the Lesson 9 lesson practice. And we are going to be using some formulas in geometry and some formulas that aren't really geometry to solve some problems here. So the first thing we're going to do is find the perimeter of a triangle with congruent side lengths all equal to 6.5 meters. Why, that sounds like a regular triangle. And to find the perimeter of a regular triangle, that's simply going to be 3 times the side length, 3s. Okay, what am I going to plug in for s? I'm going to plug in 6.5 meters. And 3 times 6.5 meters is equal to 19.5 meters. That is my answer. Let's move on to letter B. Find the perimeter of the rectangle. Well, for a rectangle, the perimeter is 2 times the length. I'm just going to use a regular L plus 2 times the width. Well, that's going to equal 2 times, let's see, I'm going to use 145 centimeters as the length, plus 2 times, I'm going to use 123 centimeters as the width. What's that going to give me? 2 times 145 is 290, so 290 centimeters, plus 2 times 123 is 246 centimeters. And then 290 plus 246 is going to be 536 centimeters. That would be my perimeter there. Okay, 2 times the length plus 2 times the width. Let's take a look at letter C. Find the perimeter of a 6-sided figure with side lengths that are all equal to 16 inches. It doesn't take that much thinking to figure out that just like a regular triangle is 3s, a regular n-sided figure is going to be n times the side length, n times s. In this case, n, the number of sides, is 6. So it's going to be 6 times s is going to be my perimeter. Equals 6 times one side is 16 inches. 6 times 16, well, let's see, 6 times 10 is 60, 6 times 6 is 36, so this is going to be 96 inches. And if I'm going to be consistent, I should probably put inches there too. All right, moving on to the next one, letter D, find the area of the rectangle. Area equals length times width for a rectangle, which is going to equal 21.2 feet times 14.5 feet. I don't have a good way, I don't have a calculator. You shouldn't need a calculator for this, so I'm just going to do this the old-fashioned way with a long multiplication problem where I know that I'm multiplying feet squared. There we go. All right, doing the next one, letter E. Find the base of a rectangle with an area of 12 and a length of 6 centimeters. So here's the thing about these ones. You can't always count on being given a value or values on the same side of the equal sign. Here, the equation is area equals length times width, okay? And I'm given the length is 6, but the area is 12. And I'm left with looking for width on the other side. Well, this is a really easy one to solve because I'm just going to divide both sides by 6. 12 divided by 6 is 2. I get 2 equals the width, and that's 2 centimeters. So the width is 2 centimeters for this rectangle. Letter F, use the Pythagorean theorem, which is a type of formula to find B. Here again, I need to make sure I'm being very careful in applying the Pythagorean theorem and thinking about what I know on what side of the Pythagorean theorem. So I have to do the 2 legs squared. 8 squared plus b squared equals 10 squared. This is going to be 64 plus b squared equals 100. Or b squared, I'm going to subtract 64 from both sides, equals 36. That means that b equals 6. And then letter G, use the Pythagorean theorem to find the area of the triangle. Find the area of the triangle with a hypotenuse of 17 and a side length of 15. So this is going to be the same sort of thing. 15 squared plus, there's some side I don't know, squared, equals 17 squared. So 289. This is probably going to work out to be something nice here. Let's see. If I take, I'm going to subtract 225 from both sides. 289 minus 225 is going to be 64. It did work out to something nice. B squared equals 64, and that means that B equals 8. But I'm not done yet. because that's just the length of B here. And I'm asked to find the area of the triangle. The area of a triangle is this formula. Area equals 1/2 the base times the height. And let me just think about this for a second. The hypotenuse was 17, a side length of 15. I should really draw this out so that I know what I'm working with exactly here. So if I draw a right triangle, I'm not going to draw this to scale or anything. I'm just going to draw the picture so that I know what I'm looking for. The hypotenuse is 17. I have a side length of 15. And then the other side I just calculated to be 8. And then, so I see I have my base, because I have the two legs, I have the base and the height. I can't use the hypotenuse in my calculation because that's not the base or the height of the triangle. So this is going to equal 1/2 times 15 times 8. 1/2 times 8 is 4, times 15 is 60. So this is going to be 60 centimeters squared. Millimeters squared. All right. Let's go on to the next one. Letter H. This is a non-geometric formula. If it is 0 degrees Fahrenheit, what is the temperature in degrees Celsius, round to the nearest tenth? So it's going to be 5/9 times the Fahrenheit temperature minus 32 is going to give me degrees Celsius. I'm looking for degrees Celsius. So what I'm going to do with this is plug in what I know. C equals 5/9 times 32, let's see, 0 minus 32. So this is going to be 5/9 times negative 32, negative 17.8 degrees Celsius. Okay? And then the last one, letter I. There are a lot of these this time. Let me just move all of this up. And we'll put a letter I down here. Now, I'm just going to use the same formula, but I'm going to plug in Celsius instead. So I know it's 100 degrees Celsius equals 5/9 times the Fahrenheit temperature minus 32. And now I'm going to multiply both sides by 9/5. That gives me 900 over 5. 180 equals F minus 32. I had to add 32 to both sides. I find that the Fahrenheit temperature when it's 100 degrees Celsius is 212 degrees. So it'd be 212 degrees Fahrenheit if it's 100 degrees Celsius. That makes sense because that's the boiling point of water. All right, that's how you work formulaic problems. You write out your formulas and you plug in the numbers that you know to solve for what you don't know.